Hi everybody, Mr. Rubo here. And yeah, today we're going to continue with the properties of quadrilaterals. And yeah, we're going to start with an always, sometimes, never. So today there's actually going to be a lot more of just you practice and then come back to the video and we'll kind of talk through each answer. This is one of those cases, we're going through the properties of the quadrilaterals, answering these always, sometimes, never. So go ahead, take a minute or two, answer these seven on page 5-6, and then come back to the video and we'll go through them. Okay, so here we have the diagonals of a parallelogram are congruent. For this is sometimes, right? So technically a parallelogram, all they have to do for the diagonals is bisect each other. But if it's like a square, then they are congruent. So that's why it's sometimes, right? So if you're using that sheet from a couple pages ago, um, the more specific you are, like if anything has those properties below it, it's going to be sometimes unless it's on that same one. So diagonals of a rectangle are perpendicular. Again, this is actually another case where it is sometimes, right? For rectangles, they don't have to be perpendicular. They just have to be congruent. If they are perpendicular, then it becomes a square, okay? And then for number 3, the diagonals of a square bisect each other. That is always true, right? Because this is always true with diagonals bisecting. That's always true for parallelograms. So a square is a parallelogram, so we're good. 4, the diagonals bisect each other of a trapezoid. Well, if it bisects each other, then it actually becomes a parallelogram, which trapezoids are never parallelograms. So this is never. Number 5, consecutive angles of a parallelogram are congruent. Again, it happens, but not all the time. This would be sometimes. This happens with a rectangle or a square, but not any parallelogram in general. Consecutive angles are just supplementary, right? And then lower base angles of a trapezoid are supplementary. This would be never. They are congruent, and if you have, you could try to draw it. If they're congruent and they're supplementary, well, that only happens if they're right angles. And you can't draw a trapezoid with right angles as the base angles because those would also be right, which then means you have a rectangle, right? So it's not possible to do that. And then the last one, consecutive angles of a trapezoid are supplementary. Consecutive meaning here just next to, and this is sometimes true. This one's a little weird because this is actually just sometimes true inside of the trapezoid, right? We know like these two angles are supplementary, but these two angles are not, right? We don't know. They could be congruent, but they don't have to be. That would make it an isosceles trapezoid, but yeah, we get it within its own shape. Trapezoids is sometimes consecutive angles are supplementary. All right, cool. So now we're going to jump to page 5-9. And this is a little bit of practice for you. So you're using your properties to set up equations based on really what shape it tells you. So go ahead, try out this page again. Try it out. Pause it if you need to. And then come back and we'll go through it in a second. All right, cool. So we're told this is a rhombus, and then we're told angle 8 and angle 7. Well, rhombus, since we're given diagonals here, that's really helpful because we know all 4 of these diagonals are right, or they perpendicularly bisect each other, which means those are all right angles, which means I can say 8x equals 90. Okay. And then we can go ahead and solve from here. And yeah, that's not a great number, but it works. It's okay. So yeah, we get, what is that? 11 and, ooh. So what happens when you've been sick for a few days? Your brain power goes down a little bit. 2/8, 1/4. Okay. And then we're looking for PNM. So we're looking for this angle here. Okay. And basically, we know that this angle and this angle are alternate interior angles. These three have to add up to 180, which means we can figure this out pretty quickly. So we'll say that this guy is 33 and 1/4. So then if we do a little bit of math, really it ends up being 90 minus 33 and 1/4. So yeah, 4/4. So that's 3/4 and 56 and 3/4 degrees. Hopefully. Yeah. And oh, my thing just went crazy there. Okay. So let's move on to number 2. So here we are given parallelogram MORS. So we know that M is x plus 3y, O is x minus 4, and R is 4y minus 8. So we know opposite angles are congruent. So we can set M equal to R, but we also know that consecutive angles are supplementary. So we could actually either do M plus O or O plus R and solve it either way. So I look at this and I see, they all have X's and Y's, so it really doesn't matter. So let's just go ahead and say X plus 3y equals 4y minus 8. Okay, and then it's a nice little system. All right, subtract that over. So now we got to set up a second equation. And yeah, let's just go ahead and say X plus 3y plus X minus 4 equals 180. So you get 2x plus 3y equals 184. If I multiply this guy by 3, I get 3x minus 3y equals negative 24. Add straight down. 5x equals 160. And you divide by 5. And you get that x is, what? That's 32. So x is 32. But we're looking for measure of angle S, which ends up being the same as measure of angle O. So 32 minus 4 is 28. So there we go. So go ahead, take a look at that. And yeah, let me just check something while you look. Awesome. All right. So now, last question on this one is, there we go. The angles of a rhombus are 60 degrees and 120, and the shorter diagonal is length 2. Find the perimeter of the rhombus. Now, this is always one that like people are like, oh, I don't know how to tell. Like you can't assume length, but because we know how triangles work, we actually know that, and you can kind of tell too if you exaggerate the picture, the obtuse angle is going to always be across from the longer diagonal, and then the shorter diagonal is always going to be across from the smaller angle. Okay. Now, one of the nice things that happens here is because this is 60 degrees, if I look at just this triangle here, that's 60. These are the same length, which means these have to be 6. So let me redraw this. So I have this triangle. This is 60. These are the same length, which means this is 60 and this is 60. which means we have equilateral, which means if this is 2, these are all 2, which means 2 plus 2 plus 2 plus 2 is 8, that's our perimeter. Okay, so there you go. Hopefully you tried these out and they weren't too bad. All right, now we're going to jump a few pages. And again, this is more of a practice page for you. Go ahead and try out 5-25. You are given the quadrilateral coordinates here for A, B, C, and D. You're also told they have midpoints, W, X, Y, and Z. And I want you to go ahead and try out this page. Okay. So pause the video, come back, and then we'll go through it. All right. So hopefully you figured out it was a parallelogram. Now, we're looking at the inside figure, not the outside figure. So if W, X, Y, Z, you find all those midpoints by doing midpoint formula. So you can see here I have all of those midpoints. Then I did the distance formula between each of them, okay? And it just so happened opposite sides were congruent, which means it is a parallelogram. And again, coordinate proofs, you're using distance formula a ton. Technically, you could have also done slope, right? If you found that the opposite sides were parallel, then it's also a parallelogram, right? So either way of doing it is perfectly fine, but you should have found out that they were parallel, or I'm sorry, that it was a parallelogram. And here you can see I did it with the slopes as well. So you could have done it either way. Both ways are 100% correct. And yeah, sweet. So yeah, I think that is it for this video. So thanks for watching and have a good day.